Alright, looks like we are live. Hi everyone, I'm TigerHawk3, and today what I thought of for the stream at the last minute is we're going to animate a GIF in Tkinter. You're not really supposed to, but that's what we're gonna do. So, we're going to import Tkinter. What else are we going to import? Hang on. This is going to use PIL. We will need... It's because I've done this before. But we're going to need these things. So this is going to be a minimal example sort of thing. That's what I'm shooting for. PIL is the Python imaging library. To be specific, it's the pillow fork. So if you're doing this, you will need to download and install that. You can probably do pip install PIL or pip install pillow, one of the two. I'm not quite sure. The internet will tell you which one. And I'm going to need these things. So let me look at my notes. Okay, first I'm going to make a Tkinter kind of framework program. Def app. No, this is supposed to be a class app, and it's going to have something in it, probably an init. And root equals tkinter.tk. This is our main tkinter object. And then we're going to make our app, which is an app, and we're going to send it this tkinter object. And then we're going to start the main loop. And this is going to need the parent object, which is this root over here. That's what we're sending. And right off the bat, we're going to go how about, I think we need a canvas. Yeah. Self.canvas equals tkinter.canvas in the parent object. And the height is going to be, how big is it? What's the size of this? I just want to set it to the proper size. How big is it? Doesn't say here. Can I add dimensions? No, I don't know how big this is. That's annoying. Anyway, hopefully it'll... Let's just do height equals... actually, let's do width first. Let's spell it right. Width is gonna be... I don't know, 700 by 700. I'm really not sure how big this file is, but we could certainly detect it in various ways. I'm not interested in that part right now. Parent, we have the width, we have the height. That should be good for now. Self dot image. We're gonna have an image. That's gonna be our image sequence. What is the background image? What's that part? Oh, we need this sequence. Okay. Let's call that our sequence. So, image, why don't I have the whole thing here? It looks like I have the start of a list. That's not good. My notes are incomplete. My notes have a Syntax error. That's not good. Oh, here we are. Oh, there's more. Yes. Okay. Sequence, there was more. Okay. I realize I have way too many things open in Notepad++. It's okay. It handles it. So we're going to use image sequence, a class in, is that a class? I'm not sure what that is. Hopefully, because it has the camel case used in classes. But we're going to loop over each image in the image sequence dot iterator. This is where it's grabbing each frame of the animation, and we have to tell it which image we're using. So that's image dot open. What the heck is F? Back to the notes. Oh, a file name. Okay. I'm gonna hard code that. Just FYI. Image.open. I believe it is F documents Python scripts, and then here's the name. I'm gonna copy that over. .gif, and I think that's it. Yes. We're gonna open this, and here's our iterator out of an opened image. Now we have to write the rest of it. Image.open, etc. So what will we do? For each one of these images that we open, we need to open it as a separate image. So we will have, as you see by the square brackets, a list comprehension of images. Image tk dot photo image, and this image tk dot photo image is so that Tkinter can have images that it can understand, created from the PIL images. Image.open, which is one of these. Is this this is a directory, isn't it? No. Hang on. What is this stuff? Sequence dir and file name. Photo image. Is this something else? Image dk dot photo image. Image. Oh, this is different. What am I looking at? Oh. Oh, here we are in start animation. I see. So it's actually this thing. This. I should probably close some of these. I don't know. So we have our image. What image is that? I don't know. I thought I had reasonable notes, but no. We need our image sequence, which is... I don't know where that part is. Like I said, I haven't done this in a while, and I haven't looked at this code in a long time. We have our sequence. This is our animate. What are we doing with this? Image sequence is this thing. Let me find all the instances of that. Oh, this is for a sequence, not a GIF. I see. And this is for an animation. Okay, gotcha. This particular program allows you to get a GIF and open that and run it as an animation, or to get a folder and kind of assemble all the images in it in a sorted fashion. Let's just copy it in there, I don't care. To get all the images in a folder and display them as an animation. I'm going to paste that in here, and then I'm going to change it. Image in... Let's not actually resize it. Do I need to do that? I don't think so. For image in image sequence dot iterator, we have that. Photo image, okay. We don't need to resize it, but we do need the image. I think this should work. I hope. So we need that. And now we're going to create an image, self.image. And this is going to be our background image that we're going to repeatedly reconfigure. Canvas, and we're going to use the canvas's create image method. Now we need the size 350 by 350. Image equals what's this? Self.background image. Oh yes. Background image. Sequence 0. We want that to be the first image that we'll start with. Okay. Very good. What else? What else? This probably won't work. I'm sure I'm missing something, including a closing parenthesis. That would help. Let's see. We start that and we run it. Is that it? Animating. Let's have that. This is going to be our flag of whether it's animating or not. Animate. Now we need some. Now we need a function, a method. That's what it's going to be. Def animate. Okay. That's good. Should be fine. Oh, we need a counter also. This is going to be looking like it's recursive, but it's not actually using recursion. It's just having scheduling calls, and those calls will schedule more calls. We should probably save this because we will need it. Parent.after. We need to actually do something first. Self.count canvas.item config. There we go. We're going to configure the image that we have up here, this created image on the canvas. And we're going to say this image is now self.sequence counter. So it's going to take the next image in the sequence. And then if not animating, self.animating. So if we have like a hotkey or something, the key that we've bound, we can turn self.animating on and off, and thus, you know, stop the animation if we want. After, let's say, just hard-code it to 33, and this is going to be 33 milliseconds. Here's our function wrapper that we're going to use, and we're going to have self.animate. Counter plus 1. If counter plus 1 is less than the length of the image sequence, else 0. Can we simplify that? So I want to increment the counter as long as it's within the length of the sequence. So if it has 10 images in the animation, then I want to go all the way up to index 9 and then back to the beginning. So how about, let's use modulus. Length of the self.sequence mod counter plus 1. Okay. Animate this. Looking at all my parentheses. That should be it. So we're going to send counter plus 1. All right. So we will start animate, and we will send it. We're going to get the length of the sequence, so that would be, for example, 10. And then we would divide by 1 more than the counter, so we were on image 3. This will divide by 4 and get the remainder, and that is 4. So then it would proceed with 4, and so on until, let's say, 8. If the length is 10, then it needs to go until 9 and then stop. Does this need to be -1? 9 divided by, let's say, 9 is 9, remainder 0. So if we're at index 9, because there are 10 images, we're at index 9, and off by 1 errors are always fun. We're at index 9, and so we increment that to 10. Hang on. We have, let's say we're at 8. And then we increase it by 1. And we want to get to 9, and that would be fine. Do we want this -1 in here? I'm not sure. Let's start one of these. If the image has 10 images within it, 10 mod Why am I'm here? I know what this is. I just have to figure out the off by one-ness. I want it to go to 9, and then when it increases by 1, that would be 10 divided by 10. I think I do not need this. So it's 9, and that'll be the last one, because 10 divided by 9 is 0, remainder 9. And then it'll be 9, and we will increment it to 10. And that means we'll be at 9, and that's good. And then we increment to 10, and we get 10 mod 10 is 0, so it will send 0. This should work. Okay. Should we try it? Feels like I'm missing something. Let's save this and run it and see what happens. Might not work. I don't know. GIF animate. Great. Now let's run it and see what errors we get. GIF animate. Let's see what happens. What is the lovely error I get? I'm sure there will be something. I didn't pack the canvas. That is important. Yeah. Let's try that again. Is it moving? I don't think it is. I didn't call. Let me show you what we've got there. We've got this. This is what I gotta do. We've got a lot of empty space in the canvas. I can reduce that, and let me do that like so. Give me one moment. I'm getting the size of this. There are ways to get the size of the image, but I'm not super interested. So here's what I'm gonna do. It is approximately 100 on each side. So about 400 by 400 is what I need. So let's do 400 and 400, and now the middle is 200. Not 20, 200. And how about animate 0? Because we want to start at 0. Okay, let's try that again. Error, integer division or modulo by 0. Okay. That's quite correct. Yeah, can't do that. Let's see. So this splendid little thing was giving us counter was 0 sometimes, or counter plus 1 was 0. Animate 0 would send 0, and then we would have length of the sequence mod. Oh, it was mod counter instead of mod counter plus 1. I forgot order of operations. There we go. It was doing length of the sequence modulo by counter, and then it was adding 1. So it was doing modulo 0 and then adding 1. That's divide by 0 and give me the remainder. You can't divide by 0. So let's do that again. Nothing much happening in there. Let's see what's happening in this. Print, how about counter? I don't know. Something like that. And let's try again. 0. It stays at 0. Okay. This marvelous little thing didn't quite work the way we thought it would. Divided by 1, 0, remainder 1. Let's play with this again. So we start with 0. Let's write a function with n. Oops. Forgot that part. I'm going to return 10 mod n plus 1. Okay. We start with 0. I did the thing again. It counts. It certainly does. So we start with 0, and it's doing the... no. Wrong direction. Modulo n plus 1. There we go. 0, we get 0. 0 plus 1 is 1. 10 divided by 1 is 10, remainder 0. Oops. Okay, that's wrong. How about f of 1? We also get 0. It's supposed to be 10 divided by 2. Now we get 1. But why f of 1 is 0? Did I do something wrong? Should be 1 plus 1 is 2. 10 mod 2 should be 0, remainder 2. No? Is 0. Oh, because it's divisible. No. Is this backwards? This might be backwards. I'm very mathematical. N plus 1 mod 10. Does it have to be this direction? I think it might. 1. Let's try 8 is 9. 9 is 0. Very good. I do have it backwards. Oops. I promise I can mostly do basic arithmetic. Let's take this over here and put it on the other side. Whoops. Backwards. That's fine. Let's turn this back on and see what happens. Wow! And it spammed us with zeros. Let's not spam ourselves with zeros. It's totally animating. Can you see that? I'm gonna move this over here so that I can point to it. Look at that. It works. It's best if you don't have your arithmetical expressions actually backwards. That's not so good. But yeah, that's how you do it. So to recap, this really would have gone better if I didn't have things backward, wouldn't it? Anyway, we're going to save our parent object because we will need it for calling after. We have a canvas. That's kind of necessary. We have to pack the canvas so we can see it. We found that out pretty quickly. Here's the GIF animation-ness. Here's all the images in that. It's the image sequence dot iterator. You can look that up in the pillow documentation. It's a thing. And so for each image in that sequence iterator, which is sent, we have to first image.open the file path for our GIF file, and then we send that opened image to the image sequence iterator, which unpacks it into an iterator that produces images. And then we have to make an image that Tkinter can understand, because natively Tkinter only supports like GIF and like PBM something, some format I'd never really heard of other than with Tkinter. So basically only GIF is all Tkinter does, and only the first frame of them if it's an animation. Granted, if you do have an unpacked GIF, if you have a bunch of separate single frame GIF files, you can just make a list out of those and loop through them like this, but this will get an actual saved GIF animation file, and or this will get an actual GIF animation file and open it into a bunch of images, which you change into something that Tkinter can actually handle. That's our sequence of images. And then we have, we set the first one as our initial image, and that's a created image on the canvas. The Tkinter canvas has a bunch of methods similar to this: create image, create rectangle, create oval, create line, I think, that sort of thing. Create image is what allows you to just place random images on a canvas. Pretty handy. This we didn't strictly need. I'm just gonna take it out because we just don't need it. You would need that if you wanted to be able to, set self.animating to false, and then it would stop, and then you would need some way to call this animate again. And here's the start of the madness. Calls our animate function, starting at 0 for the first image. So immediately the first thing it does is reconfigure this image that we have and set its image to the next one of the counter. We should probably call this 1, technically, because we already set it to 0. I'm going to make it 1. Doesn't really matter because it's only there for a 30th of a second. Self.sequence. So on the first time we call this, it's going to set this to self.sequence 1, because we started at 0, and then we will go to 1, and then it's going to schedule a call here, and it's going to schedule a call to this function, this anonymous lambda, after 33 milliseconds, and it will call this method again. It's not actually recursion, because nothing is saved on the stack or anything. It's just, it doesn't call itself, it just schedules itself. Animate is actually calling the parent object's after method. And it just so happens that after this amount of milliseconds, this function is going to be called again. Not actually recursion, technically. And so we're going to call self.animate, and all we need to do is increment the counter. And so we're going to increase it by 1, and then do a modulo of the length of the sequence, and that is going to be basically counting up through all the elements of the sequence until it gets to the maximum, at which point it goes back to 0. This thing and this one, don't invert them. As you saw, that's bad. So yeah. And then the standard Tkinter stuff. Let me save this. Make sure it works. Works. And of course we can slow it down. See, that's pretty slow. And we can speed it up. This is the delay in milliseconds between frames. Now note that if you have a GIF that is created with some kind of nice GIFing tool that optimizes things, if your animation has some sections that remain the same throughout the animation for some period of time, it may leave subsequent frames not drawn or maybe transparent in that area to just save some space. And so you'll get weird results when you do this because it is replacing the entire previous image with the next one. It's not kind of layering them one on top of another. There's various techniques to get GIFs to actually look good while still being small. GIFs also have a limited color palette. I think it's like something small, like 256 colors, or is it like 8-bit? I don't know. It's pretty low. But that's only per frame. So you can pick that many other colors for the next frame, whatever's necessary. So using all these little optimization techniques, you can make a GIF that looks pretty good, but it will still be very gigantic compared to an actual video file. Which is why a lot of these GIF sharing services like Imager and Giphy, etc., are also processing the animations they get into actual videos, and they have a version of the file that's an actual GIF animation and a version that's a video, and the video one is generally smaller by a factor of like 10 because it's actually supposed to be a video format and not just a kind of hacked together, I guess we can make something look animated if we change if we change the picture to lots of different contained pictures. But that is how you animate a GIF in Tkinter. It works mostly, unless your GIF is optimized, in which case it'll look blotchy and weird. I have seen it before. It's kind of disappointing, but generally it can be pretty good. And if you have just a sequence of images, not an actual GIF animation, then you can just put all those images into a list like this instead of getting an image sequence.iterator. You just open all your files and make Tkinter images out of them, and then you just loop through that. But this is the basic idea. Hope you enjoyed the stream. Tomorrow will be a game. Day after that, I really don't know, but probably Python something. I don't know. If you have suggestions, I would love to read them in comments. So yeah, thank you for joining me. I hope you learned some stuff about GIFs, and I'll see you next time. Have a good one.